Yo, what's up, everyone? Good morning. It's not even Wednesday for me, if we're being honest. Come on, man. It's Thursday morning, but I mean, I think that's fine. I think most people are doing the work later, and I think it's just working. So I wanted to say, if you sometimes wait and watch the videos during class, I really do try to get them in on time, but I mean, sometimes I just get distracted. So either way, the good news is this is just a review sheet. And as I was making it, I realized that there's not even that much I really even need to cover twice, if that makes sense. Like the first three lessons for this set, I think were pretty concise in explaining this topic. Um, and this one is just going to do everything one more time. So what I decided to do, especially because I'm sending it in on Thursday, is there's just two example problems, no practice problems. So just do them with me, and then the quiz is going to look super similar. Okay, to actually just like the second question as a setup. If I'm, I'll just tell you. I don't think it's good if you're watching the video to know exactly what's going to happen. But yeah, let's talk about the normal distribution one last time. Next week we have a week of school, but then the week after that we have a week off. So after week 5, there's a whole week off. So things are looking really good. Life is looking good. So yeah, let's talk about the normal distribution. It says wait times for the drive-through at Chick-fil-A are normally distributed with a mean of 25 minutes and a standard deviation of 8 minutes. And the first thing to know is that in the normal distribution, you can't solve anything without the mean and the standard deviation. And that means that you can't even sketch it without those two things. So if you're given those two pieces of information to start a question, that's usually really good news, because the alternative is that you're going to have to start by solving one of them. Okay. So if you're given the mean and the standard deviation, um, think that we're trying to still solve the z-score formula here. And you already have these two parts. And the questions themselves are just going to revolve around converting percents to z to data point in the other way. So yeah, we have the best parts of this. And sketching, hopefully you at this point think it's just kind of fun and easy. You put the mean in the center, and then you go left and right 3. Now, crap. These numbers are also like, you should put them in, but I don't even know how much you even need to memorize this year. Like, it's pretty likely the AP exam is going to be open note. Crap, I messed up again. So I personally, and I think in math in general, just like the logic is more important than memorizing things anyway. But yeah, I'm just talking because I'm writing it in, so it's stalling. But yeah, those are the numbers. The mean is in the center, and then you add and subtract the standard deviation. And that's because this is basically saying that 68% of my data falls within one standard deviation, right? So 17 to 33 is one standard deviation away, and 68% of the data is there. So I'll fast forward through the rest. Cool. Good. So we have the distribution itself, and now let's kind of run through the different types of questions you could have to solve. For B, it says 80% of the time you have to wait at least how long for your meal. So we have percent, and percent is the only thing that you could be given that's not part of the z-score formula. Okay, and I'm sorry for the slight glare. What I mean by that is that if you're just going to be really formula technical here and look at the formula and be like, oh, I need to find 3 parts of this, the percent is not one of them. So you just have to remember that percent and z-score are the big conversion that you're doing all the time. The rest of this is usually given or you're solving for it, but the z and the percent are like the big reason we even have the chart and all that. So 80% of the time you have to wait at least how long for your meal. So the wording of these is always tricky, right? You have to figure out, does this 80% mean above or below the point that we're talking about? And for me, a lot of times it just kind of helps to say it out loud. And I even pause for a second to make sure I was doing it correct. But it's saying 80% of the time you have to wait at least this long, right? So if let's say it was 17, it's saying you're waiting at least 17 minutes. So 80% is 17 or whatever this data point is or above. Okay. So I think that's really hard. And if you're trying to visualize it on the distribution, it's saying 80% of the time, we're going to wait at least as long as this point. Okay. And we want to figure out exactly what this point is. So the way I like to write this is I figure out if it's percent above or below that's given to me, but I know that I can only put in percent below in the chart. Okay, so 0.8 is the percent it tells us, and it's saying 80% of the data is above the data point we're solving for. But we know that the shaded region in the normal distribution is below the point. So we're looking for 0.2 within the chart, whatever is closest to it. I hope that makes sense. So negative 0.84, a pretty common one, and that's going to be our z-score. What that means is that the data point we're solving for has a z-score of negative 0.84. Okay, the data point that has 20% below and 80% above is the z-score negative 0.84. Okay, so once we have that, we have the mean and standard deviation. That's when we solve for data point. So negative 0.84 equals, I'll just call it x this time, minus 25 over 8, and just multiply by 8 and then add 25. So like 19. That was a guess in my head. So like, of course, I'm being cocky, but I'm proud of myself for guessing 19 just by looking at that. But yeah, that's the data point. And in the context, it makes sense. 80% of the time, you have to wait at least 18 minutes for your Chick-fil-A. So for me, always tying it back to, does that make sense? What it's asking, does everything I do make sense now that we have an answer? But we have an answer, 18 minutes, which I think is pretty accurate. Good. We're going to continue on. If it takes 40 minutes to get your food, what percentile are you in? And I'm just trying to cover like a bunch of random different types of question here. But it says, if it takes 40 minutes to get your food, what percentile are you in? So we have the data point, okay? And we can even visualize. We're trying to figure out the percentile for this data point. And all you need to realize about percentile is just what you'd expect. And that's what percent of people are worse than you. And what's funny and interesting is like in this case, you actually want it to take as little time as possible, right? You'd rather have your Chick-fil-A take 1 minute than 50 minutes. But percentile is always going to measure what percent of data is below that point. So this is going to be really straightforward. The data point is 40. We have these two, so we want to find the z-score. And then once we convert the z-score to percent below, that is the percentile. So 40 minus 25, 15 over 8, 1.88. That was an even better guess. I'm really proud of myself for that one. That was the z-score. I have to do something to entertain myself, guys. 1.8. 1.85. And I'm going a little quick. Actually, it's 1.87. I have to make sure that we're still being really effective here. But the z-score was 1.87, which actually we could convert. We should estimate to 1.88. So I'm looking for the percent below the z-score of 1.88. So 1.88, right? So this tells us that you're in the 97th percentile, okay? If your food takes 40 minutes, you're in the 97th percentile, which in this case is really bad because 97% of the food takes less time than you to order. So again, we got the z as 1.88. We converted that to percent below, which was 0.96. Okay, good. I'm going to skip D because I actually want this to be a pretty short video and I think it's going long. but E is new. E says that a z-score of negative 2.4 is what wait time? And what you should see here, the reason I'm doing this and not D, is that you can start with a data point. You can start with a percent that you have to convert to a z-score, or you can start with a z-score. And if you start with z-score or are asked to solve for a z-score, think that it's really easy because you get to skip a step. All I'm saying is that we have the z here as negative 2.4. We know the mean and the standard deviation, and we're trying to find that data point. So we don't even need to use the chart. Here, we already have the 3 pieces of information we need. So we have negative 2.4 equals x minus 25 over 8. And that's going to tell us what wait time is associated with this z-score. So we don't even have to talk about the percent above or below. So I hope that makes sense. We're saying this is 5.8 minutes. Excellent. I know I rushed through that, but I think that question is a little easier than the second one. And I want to talk about the second one because it's going to highlight what I believe is the hardest thing we did, and just an approach. So for 2, it just says the average height of humans is normally distributed with a mean of 65 inches. And if 90% of humans are taller than 60 inches, solve for the standard deviation. So first, what I want you to remember is that some questions, like the last worksheet, I thought was really hard because you just got a block word problem and we're asked to solve for it. And what's difficult, what I mean by that is that I'm really setting you up here, right? We have the mean and we have this piece of information, and it's going to help us solve the standard deviation. But anytime you have to solve anything related to a normal distribution question, this should be what you solve for first, okay? Because I could have asked you, and like this is just an idea, like I want you to understand this, or the AP could have asked you something like the average height of humans is normally distributed with a mean of 65. If 90% of humans are taller than 60 inches, 99% of humans are taller than what height? A question could have gone from there to there and asked you to solve it, and you have to solve the standard deviation first. Does that make sense? So yeah, I'm trying to guide you here, but the key to any of these questions is the mean and the standard deviation are the most important. So if we're given this, if 90% of humans are taller than 60 inches, we have to convert this to z-score, okay? We have our data point and we have our mean. The mean equals 65. We're talking about the data point 60. And we know that 90% of the data is above this point, okay? It's saying 90% of people are taller than this data point. So 90% are above this. So we want to convert this data point to z-score. And we're going to start by putting a 0.1 in the chart, okay? So this data point of 60 corresponds with whatever puts 0.1 and 0.9 here. So actually what I already ended up having. So negative 2, 1.2, 8 is going to be my z-score. So the only way that we could solve for the standard deviation is if it tells us information about this data point, right? So negative 1.28 equals 60 minus 65. Over x, and then we'll have the standard deviation, and then we can draw and go from there. So negative 1.28x equals negative 5, and it's going to be around 3. Perfect. The standard deviation was 3.91. Now we could sketch it the center is 65, and we're going left and right by 3.91. Too lazy, I'm not going to put the numbers in, but yeah, that's what the distribution would look like. And then if it says 99% of humans are taller than what height, we're now trying to find that data point, okay? So I don't even want to finish it because I think this video was already pretty good to understand things. I actually have accomplished what I wanted. But yeah, if you need to, I'm going to finish it on the answer key, so check your work. But I really just wanted to tell you about the mean and the standard deviation stuff. And these are really the only types of questions you could be asked. Okay, so these are the 3 types. But yeah, really good work, and I appreciate you guys.